this is my neutral, so that's going to be my return path. And then I've already hooked up the case ground. Now this one here, I would assume.
Sorry, what's the order that you hooked up cables in?
Green case ground would be same as the other one. You're going to do the green case ground first, then your high voltage lead in return. It doesn't matter. And again, it's supposed to be on system neutral, but this is acting as a system neutral because I only have that.
How about a driven ground rod for that first connection? Is that
We don't recommend you take a ground rod and drive it into the ground. And really, it's for safety reasons. And the biggest reason would be is if this were to be energized and it would be backfed and you didn't drive that ground rod into the ground deep enough, what if that shot and all that voltage, everything coming back, would actually dislodge that from the ground? That would be the reason. If you're hooked up on your system neutral inside that transformer, it's pretty unlikely that would happen there. So that would just be another level of safety for you guys to make sure.
But it would work.
Yeah, technically it would work. We just don't recommend that. We recommend you go to the system neutral. We feel like that's a safer connection.
Some questions were brought up in the past on both these units. Does it matter which way you flip-flop these guys? One before the other?
Okay, I would always have the case ground, the green cable be behind. Always have that cable be closer to your elbow. That makes sense?
Oh yeah, that was the biggest question was if guys reversed them or if we hooked that over on the junction side and then that one closer to the elbow.
Yeah. And ideally, for that return, if the elbow's here, where we're hooked up, ideally I want to be like 6 to 8 inches away on the neutral of the cable that we're testing. Now, I know all your neutrals are tied together, and that's one of the common questions that gets at, what difference does it make if all my neutrals are tied together? And the reason is you're going to get a better radar picture. A couple things are going to control your radar. One, I'm on the neutral of the cable that I'm testing. Two, I'm 6 to 8 inches away, and I take that connection point and I clean it. Take your wire brush out, get all that dirt and debris and crap off of there so you have a more solid connection, because the more things that get in the way of that, it's going to affect what your radar picture is going to look like. So what you want to do is control the things that you have the ability to control, right? You have no control if your neutrals are degraded, but you have control over how you hook it up and the best way to do it. So that's the reason we suggest that you do it that way.
Second part of that everybody's asked is to isolate the concentric on the elbow or leave it connected to the system.
Leave it connected.
That was one of the big ones everybody was trying to figure out.
Yep, absolutely.
So leave all the grounds connected together, make your connections, and the main lead that's connected with your conductor needs to be as close as possible. And then the other one is just get it within reason so that you can protect it.
Yep, absolutely.
Hey, one last thing.
Yes, sir.
What he was saying, we got a situation where it's a riser, so we just cut the riser pipe and then cut the cable and just expose the conductor and hook it directly to the conductor. Is that a proper method?
That's okay.
Well, because now that ground is disconnected, so
It's isolated.
going up higher. So we just had some concentric where we cut it and then peeled it back, twisted it, and connected right here.
You should be able to still get a reading on there, so that should be okay.
Okay, because you were saying that you wanted all the grounds connected. That's only
No, you said you can't leave
ground
it
on one side.
Basically, you don't have to disconnect the ground.
You don't have to.
To test it or do this.
So you can do either or.
Right.
But the best ideal is leave everything together but isolate the conductor.
Right, exactly. So, one of the differences with this machine here is when you first, couple things. One, don't compare this to this one here. If you're like, man, we took the suitcase out and it's not as loud, because I'm gonna say, yeah, you're right. The advantage to the SST is it's lightweight and it's portable. It weighs 70 pounds. It still has a capacitor in there. Maximum voltage is 15 kV. Maximum energy is 832 joules of energy. Compare the two, designed for shorter runs. You get to up to about a half a mile or so, I'd probably be bringing this one out. Even up to a mile, you're still okay, but you're really pushing it to the limitations of what it's capable of. You guys have the larger unit for that reason. But for shorter runs, this works great. The one thing with this one is when we turn it on, it's always going to turn on in radar. So it'll take a couple seconds here. The light should turn on. There we go, contrast. So this contrast knob is just for the light on there. And it's backlit, so you can use this in the sunlight, you can use it at night. So I've actually got this hooked up. We call this our subdivision in a box. So what we have here is we're hooked up, and then I've got a couple of transformers in between. So if you wanted to use, we're talking about sectionalizing, you can use this to sectionalize. So right now, what am I looking at? If you look at the screen here, that looks like my hookup point. That's my open, and those are a couple of transformers. This also has transformer marking software built into it. So it says push the range button to start my transformer search. I push that, and it identified those two transformers. So the first one is 98 feet away. The second one is 274. And then my open end of my cable is 450 feet. Now this one here, I'm gonna take my voltage. I don't need to go to 15. We're gonna go to about 10. And you notice this has the set point on there, so you always know what voltage you're at. And I'm just gonna push the start button. And we're gonna have two transformers on here. Then we have two traces. Right marker at fault, 366 feet away. So it's between your second transformer and the normal open.
Does the bigger machine have that capability?
I have to look at the software on there to see. It may have a version of it, it may not be quite as detailed as that one.
If it's
I
software,
think that's
can
what
it be?
he was saying earlier.
Yeah.
Trying to figure out.
Right.
splices.
Let's
If it's software, can it be updated?
no, it would be replacing the whole radar.
Gotcha.
But let me I'll go into the settings on there, and I can figure out what version is on there, and we can activate it and see how it looks.
You have to isolate the secondary. Just open this one.
Say it again, I'm sorry.
You have to isolate the
No.
secondary.
So it goes through the path of least resistance. So technically, when you're using this to go through transformers like that, it doesn't even identify that your secondaries are there. It's just going in through the elbow, the bus bar, back out. Yep, exactly. So in a situation like this, what would you do? So now I've got my hookup, a couple of transformers, my normal open. Now we determine it's between the second and the open. So what I would do at this point, push the stop button. Let's isolate that section. Go pull the elbow. Go pull that the elbow to second transformer, and then isolate it to the normal open, and then do this whole process again. Radar the cable, find out where the fault is at. Then once you've done that, then you can thump the cable. We don't recommend thumping at this point. And the biggest reason is this puts out 832 joules of energy. If you thump through transformers, once it hits each one of those transformers, it loses a little bit of the energy. So we want as much energy to be at the fault as we can possibly create. So by thumping through a bunch of transformers, what you're doing is you're losing some of that energy as it dissipates at each transformer.
Can you ever damage any of the equipment, like the transformers? Somebody say, just whoa, what the hell? Push the button.
We've tried, and we intentionally, somebody wanted us to try it, and we tried to backfeed it, and we tried to do all of that, and when we did it, it was a very minimal repair. That was, I think, like a resistor failed or something. So that's when we intentionally tried to damage it. So it's highly unlikely.
And we're talking about the equipment like the transformer. Right. Damage the transformer.
No.
Okay.
Not that I'm aware of that we've ever seen or done that. I have to be careful. I say can't blatantly say no, but we're not aware of that ever happening.
I mean, it's not good to thump the transformer.
Right.
You're trying to find the fault and go isolate the cable,
Right.
and then do your thump method.
Right.
But I'm just saying, like, if say somebody was filling out, you're tired in the middle of the night, and you were just thumping or something,
Right.
Is it gonna damage the transformer?
No, it's not.
The big one, same thing.
Yep, same thing.
So even if they went to full max, it's probably gonna go to fault, not mess with the transformer. I mean, obviously, things can happen because electricity will work.
Right. There's always that possibility, but yeah, we're not aware of
But
that.
nothing has come across.
Right.
That was what I'm thinking.
Right. So when we're done, we just push the stop button. You want to thump. This one's a little, the only difference here is you push the radar thump button, it says thump mode, and I didn't point that out before. We keep this really simple. T stands for thump. There was an R on there on radar, which stands for radar. So we try to keep it simple, guys. So I'm just gonna thump it one time on here. I said we shouldn't thump it that way, but I'm just gonna go one time. So we're gonna get a snap in there. And then I'm just gonna do it one time.
What KV you start on that? Lower setting or?
This one doesn't have, it just has one capacitor on here, so it's non-switchable. So I have it set at about 10 kV, maximum is 15. So there's no setting on there, you adjust it, just do the min-max now. And this, the two features or settings it has on here is just radar and thump, and you just push the radar thump button to cycle through it.
Between switches, yeah.
That's consistent with what the radar said, right? It's 450 feet.
Yeah.
From the lens.
Yeah, so this is a different one than that than on my coil, but that's about right because we pushed that rate.
Yeah, but when we radar
Yes.
before,
Yep.
it said 450.
It was 450.
Yeah.
And we'll radar it again. And I think we had, was it 366 to the fault? I might have that number off. I don't remember.
You don't have to press the radar button once on this one, or the start button.
Oh,
So,
okay, this-
yeah, this one here, when you're cycling it through a second time. This one here, every time you push the start button, it's just gonna radar. That one there, you have to verify the two traces.
What'd the value change? Because it was 450 a moment ago, and now it's
Right, because now we push the start button to get our fault. So there's our fault at 366.
okay.
So the other difference between the two, the fault trace on that unit is on the bottom. The fault trace on here is on the top. So it's just different software that goes into building the equipment.
And then it verifies it on the screen, so you're not trying to guess.
Right, and everything else is the same. So if you, for the most part, if you can operate one or the other, you can operate both. They're very similar. There's a couple different differences, but nothing major. Yeah, they said this already has that software built into it. When we're done here, I will double check that one. I also want to check your left marker on that. I figure we don't need to, have everybody here for that.
More of
We'll
a getting
finish
it
up.
to,
Right.
to par so that we can operate.
Yeah, absolutely. Any questions, guys? Anybody else want to run this?
So you dump a piece of primary, and the snap's coming out of that wire. That means it's getting all the way to the end.
Well, if the wire's good, it won't snap at all. It'll just hold voltage.
We had a raw situation, it was actually a powder up in the air and snapping with a powder.
Now, okay,
Not, well, we had cut that powder off, but
well,
snapping.
let me rephrase that. So, when you say snapping, is it just snapping off the concentric? Or is it an actual snapping like
It
it's
looked like it was
faulted?
out for the conductor. I mean, it was.
I mean, if the cable's good, it shouldn't snap off the conductor. We have had it sometimes where, and I've seen it where you're hooking up and then you're thumping the cable and then it's snapping right there on your hookup. That I've seen from time to time, but technically if the cable's good, you shouldn't have snapping on there. Right.
So it just be fine.
If you had that same situation, what is that, what is creating that, when it's snapping right there, bad connection?
One, it's a bad connection. Two, it's just compromised neutrals. And this goes back to when we talked about the hookup. Control what we can control. You can control your hookup. You can make sure it's clean and solid and tight. You can't control that your neutrals are corroded.
And then, in that case, does this have other methods?
This does not have that current impulse like that one does.
I think we ran into that,
Yep.
where we're like, well, now what do we do?
Yeah, this one you gotta have a good neutral to be the return path of the machine.
Okay, so that's something we need to note in.
Right.
That the neutral's compromised.
If it's snapping at the end, that means the cable's bad, but why is it snapping with a fault?
It might be snapping in both.
So you guys are-
I've had that happen where it snaps on the end of the cable and then you're thumping the cable and you can still hear
Used to
it.
have some not burning clear.
Right.
Yeah, but I still have some.
Oh, yeah, it's definitely not burning the clear. Because it,
would snap. That could be so.
No, because if it's burned in the clear, this is the spot where it's snapping. Now, if you have a bad neutral, right, and let's just say the radar only gives you 300 feet, and you're standing at 1,000 feet, it's still going to thump. I mean, so you can still thump the cable even if your neutrals are bad. Does that make sense? Yeah.
It's gonna find a ground,
Right.
because it already.
What's happening is when you have an open on your concentric, in that situation, what's going on is it's not able to tell you where the fault is at because the radar's not able to see it. But because the capacitor, we're charging that down those set of conductor, it's still wherever it's finding that that gap, it's still being marked. So you can. So I guess that's one thing. Let's make sure everybody's got that. If you're dealing with bad neutrals and you decide like, hey, it's only 400 feet of wire, we're just going to thump and walk it. It's thumping at the same spot where it's bad. The problem is you just don't know where that is based on what the radar showed. You can still thump and walk it. I mean, hell, that's what people did 30, 40 years ago before there was radar. Anyway, so you have that ability. Anybody else with questions? Anything I didn't cover? You guys, you seem to use it a lot, so I want to make sure we got everything. If something comes up after today, and anybody wants one of my cards, I'll be happy to share that with you. But otherwise, they're envelope machines. If you think of something down the road, don't hesitate to call, shoot me a text, send me an email.
The isolation, kind of like what he's talking about. What's the other end got to be? Let's say we have a conductor that's going all the way through and it's got a bad spot in the middle, and it's sent it to the other end like a pothead. Is that something we need to cover? Like, what's the best isolation?
Just go pull it from everything.
Yeah, do we just leave it float there, or is it going to track to a ground, or is it?
No, you
So it
either want to have it on a parking stand or leave it in the clear. Either way is fine.
And there's
It's
not
still
a specific distance you got to have it. Just the normal, like as if it was in operation.
Right.
Just leave it float.
Yeah, because a lot of times when people do it on the other end, they'll just pull that elbow out, just leave it in the clear,
And then-
Those are the two ways. I mean, I would either put it on a parking stand or just put the elbow in the clear.
Say you cut it, and he could put off the center and have it in the clip.
Yeah.
as long as the semiconductor's back far enough, because then it will track it.
Right.
But that's what we're
So-
talking about. If you have it laid in a hole, you don't want it laying against the ground.
Right.
You want to float it.
Okay,
What
so
is
when
that?
you're
What is
saying
that
in the
distance?
clear, you just cut the cable? Because if you just were to cut the cable and just leave it, technically that's a fault. Yeah. So, here's the question. You have a cable that's got a fault here, and you have the other end where you just cut it and didn't do anything else, didn't peel the conductor, the semicon, just left it there. That's another fault. Which fault's going to show up first? Well, let me say this. It will only show you one fault. Which one is going to show up first?
Whatever one falls quickest.
Whichever one goes to ground first. Least resistance,
Yeah.
right? More times than not, it's the closer one, but not necessarily.
Yeah, if you have a lot of
Right.
distance.
So we've done this like in a training yard where they'll put a fault in the cable. They'll just, they'll drill a hole to create a fault, and the other end they just cut it, and then we will get it. And I probably should have, when you said in the clear, I should have been clear on that. What you were saying. When I think of like utility, like in the clear, I feel like you got either an elbow on the end of it or you peeled it back. But if you just cut it and that's on the clear, that's technically another fault. And I would get it where it would, sometimes it would spark in there, and sometimes that would show the fault where the hole, the one that they drilled didn't. So you just need to be aware, only one at a time. Because what you should do is, now I don't know what your processes are here, but let's just say you find the fault, you fix it. Before you leave, you should test it again, right? You can test it with your high pot test, your high pot setting. You can go to radar, you can go to thumb, but you should take it to whatever voltage you want to set that, you want to put on there to verify that there's no other fault, because you have no way of knowing if there's an additional fault.
So isolating the cable, like you said, we'll go out to a job where we're speculating there's a fault. And a lot of times in the middle of the night, we may be able to back switch it. So guys will cut the cable or try to pull it out, and then that's left like that. So if you had a non-jacketed, if you want to try to hook the concentric back into the system and peel everything back as if there's going to be an elbow on
Right.
there, and try to isolate the conductor as
Yeah.
if it was going to have an elbow on it.
Yes.
And then at that point, keep it off of ground.
Right. And then, yeah, exactly.
And maybe
That's what you would
rubber
wanna do.
blanket or something,
Right.
so that it's isolated away
Right.
from the ground.
Yeah, you just want to have it if you can.
As if it was
you
gonna
can
be
position
used.
right. If you can position it where there's nothing around it, it's in the ground, you can probably get away without using a blanket. But if there's other things around there, you just use a blanket. I mean, I've seen where sometimes in those transformers it's so tight where they'll use a feed through in there and they're still putting a blanket right next to it because damn, it's like right next to the other cable. So you got to be careful.
Yeah, because it could snap over.
Oh,
have
yeah.
something
Yep.
covering the end.
Yeah.
on
I mean,
something.
at least from what I've seen, newer transformers isn't really the case like that anymore. There seems to be a little bit more space in there to do that. But some of the older, well, we've got a full training yard down in Birmingham at our plant, and we probably have 20 transformers. Each of those transformers are donated to us by utility companies that are just getting rid of them. So they're like the happiest ones. I mean, but for us it's good. We're using it for, but it's just really old, and we've got to, sometimes when we're doing a school or any type of training there, we got to cover them with blankets for sure.
But the other thing too is we've had this before, which is glad you brought all this up. Is we've gone out there and done a cable and they can rip the central neutral on the other side.
Okay.
So that's going to create issues.
I mean, it's almost like running another neutral, right?
Well, I'm saying, like what he's talking about, where we build a neutral back, but we're not
Right.
hooking on the central neutral. We're not hooking. Yeah,
I still think that'd be
just
Yeah.
isolate.
Yeah.
As
I
long
think
as
you're
the
fine.
two aren't parking together.
Right. I think you're good.
It's still going to show you the end of the cable without it being hooked into a
Yep.
system.
I think it would. Yep.
As long as in the middle, it's the integrity's not bugged.
Right.
We did have one where we thumped it with this unit, and the concentrics were perfectly twisted, but both of them were burned off and they were like this. It didn't thump, it was thumping through the concentric out of the back connection
Right.
at the beginning. And we were getting all kinds of weird. And it was telling us like 200 feet, then it was telling us like 350 feet. We're like, well, how do you walk that out? That's a
Right.
lot of freaking thumping and walking. And it was just, we had a perfect scenario where the concentrics were perfectly burned off at both ends, but they went right by each other. And it just kept faulting here and then here and down
Right.
there. And it kept walking the whole cable.
Oh, that's yeah.
And obviously these machines aren't perfect.
Right.
I mean, in a perfect world, that's mentioned, right?
Right.
So those are things we have to take into consideration. Try and make it move to the other end. Dump it
Yeah.
back in.
Sometimes that's a
See
better
if we can
option.
at least get it
Right.
close enough where you say, okay, it's within this 50 feet, which
Right.
is stop mode. Try to find the
Yeah.
ball.
Exactly.
And I mean, to me, concentric bad, you probably ought to replace the cable anyway because it's not operating.
Diagnosis. Previous
So if you've got a good
the compressor was like here.
system
Previous
neutral on the
one,
other side,
jumper,
system neutral on
the
this side,
compressor and had it on the switch.
and you have both of the
Set it
concentrics
out
with
of
them,
like
it's gonna act the same.
Right.
If it's in.
So put it
Yes.
on the skin and
Sure.
said, yeah, that
Trying to
fuse
find
box
that
did
fault.
the way that system
It's a whole
works.
different ballgame, so that's where we were running
They
into issues.
eliminated
It's
a bunch of
burnt off
fuses back
perfectly
in the
with the wrong
computer.
section.
And with doing that, which is like part of
Again,
the
that's
canvas system, so like where the headlights is out.
That's why I wanted to get this machine up.
So instead of having a fuse where the fuse box and you have to go look, it'll tell you.
Like you have with a lot more.
Holes and all the other settings to get rid of
Right.
using that centric, because you said it's the pulse that.
If it stayed out for too long, or if you kept trying to push through.
With current impulse.
Current impulse.
Yes. It's not the
It doesn't went out. It's probably using what
Right.
it's
So you have to change
semi-con.
that fuse box out.
That's its
Yeah.
that's its fault.
I guess
And then
that
gets you
that's
more.
what I'm saying. You want to
Oh, right.
buy the new one from them and try to take them out.
Well, I hear what it sounds like. It's good information. I just don't have the attention span.
Join us after this. Join us after this.
When I did it, when I actually had it,
It's like integrated with the except that
that was just a. That was just a glitch with the. No, that won't be.
Appreciate you. How'd you like that? That's it.
But like I said earlier, once
This
that.
stuff I brought up.
No, that was that coil. The coil's a little wonky.
Sure. Appreciate it. Thank you.
After like
That's why it's
Right.
Thank you.
Right, so we always gotta, keep an eye on it. So that's why I said I like using it. And actually, see that hit right there. Almost touching that. So I think, I actually, now that I see that, I feel like the first time, that's why I was so, because I was not expecting.